So when I look at number 16, 16 has us looking at these two equations. Negative 6x plus 6y is equal to negative 4, and 2x minus 2y equals 5. Now the question is whether it's one solution, no solutions, or infinite solutions. Okay, so for it to be a one solution, what has to be the case? For it to be a one solution, when I start solving this, everyone's eyes are over here. When I start solving this, if I was to actually do this problem, how do I know when I would have a one solution? Rita? The variables don't cancel out. So, if we take a look at this, if I decide, and I want you all mentally to do this right now, for us to get rid of one set of coefficients, what would you do? What would you do to start getting rid of one set of coefficients? L? Yep. Which one are you trying to change? Which set of variables do you want to change to opposites? Right. So if they both change, what happens to both sets of variable terms? They cancel out. So that for sure is not a one solution. How many of you guys agree with that? Okay. So L did notice that they both canceled out. So we're going to get 0 on the left. So now that we know that both sets of variable terms are going to cancel out, we have to decide whether we're going to have a no solution or infinite solutions. So what does a no solution look like? Raphael? For infinite solutions or for no solution? No solution. So we're going to have 0 equals something other than 0. Okay. For us to have infinite solutions, what will our solution look like? Maggie? Yeah, like 1 equals 1, 2 equals 2, 0 equals 0. Okay. So when I look at this one, L has already told us, okay, if I multiply by 3 on for that second equation, both of my coefficients go away. So I get 0 on my left. All right, well, 5 times 3 is 15. Does my number on my right equal 0? If I was to do whatever that subtraction is, am I going to get a 0 on the right? Carmen? No. So what is that going to be? That's a no solution. So I didn't do any math at all to look at that, okay? We did some stuff in our head, like we did some math quickly in our head. So if I take a look at number 17, I'm going to do the same thing. I need to get a set of coefficients to be opposites. What do you notice about the coefficients of each of these variables in 17? What do I notice about my x coefficients? What do I notice about my y coefficients? What do you notice about them? Rita? They're exactly the same, right? So I just need to turn one set into opposites. So let's say I'm going to multiply that second equation by -1. What happens to my variable terms when I multiply all of this by -1 and then I add the equations? What happens to my variable terms? Do they go away or do we have one left? Giselle? They go away. Then, looking at that right side, are these two going to cancel each other out so I get a 0 on the right side? Maya? No. So this is a no solution. Right? So I kind of want to do the same thing on all of these. That's what you are looking at. You're looking at what math do I have to do to get a set of coefficients that are opposites. Once I do that, what then will I find? Will one of the variables still be left? That's a one solution. Are both variables going to be gone? Yes. Okay, then what happens to the other side? So you're just kind of mentally running through what that math might be. Does that make sense to you guys? Okay, having said that, are there any of these that you want to talk about specifically as you did that mental math? You guys okay with these? Okay. Are there any other problems from this homework that you guys want to talk about before we move on? You guys pretty good with systems of equations? Awesome. Put this away. Get your notes out. so I want you guys, I've skipped a whole day. It just occurred to me as I look at everything I'm doing, we've skipped an entire day. Okay, so what we're going to do is we're going to shift all of that down a day. Okay, so get your assignment notebook out. We're going to shift everything down a day. So don't do Monday's homework. That's going to be Tuesday. Don't do Tuesday. Like, don't do that yet. That will be the homework for Tuesday. Don't do it yet. We're not going to go over it yet. So don't jump ahead here. All right, so just shift all of that down. Our test is going to be Friday, not Thursday, okay? I am going to give you your homework right now. Looks like I did the same thing last year. That's so rude of me. All right, so for our homework on today, I want you doing, it's going to be on the same page. So you're going to be doing page 417, and I would like for you to do they're not story problems, so that's going to make you happy. I would like for you to do 3 through 8. Let's do 3 through 14. So 3 through 14. 22. 27 through 29. So 3 through 14, 22, and then 27 through 29. You guys cool? Does anyone need me to repeat that? I'll make that adjustment. All of that's just going to get shifted down all one day. So your chapter review is now due Thursday. That Monday night homework is to be tomorrow. Don't do it. Just wait for me to go over it. It's story problem stuff. Let's get the skills stuff done for this section. All right. So today is 3-9. We are looking at Chapter 6, Section 6. And now we're going to talk about systems of linear inequalities. All right, so now we're kind of combining together two things that we've already done. All right, let's review for a second graphing an inequality. I do need you guys to have out your rulers, please. So let's talk about a linear inequality. So that might be something like y equals 2x plus 5. Oopsie, y is less than or equal to 2x plus 5. Okay, let's remember how to graph that. Remember, you're going to graph it like it's an equation first. So we're going to graph as if it is an equation. So I'm going to graph y equals 2x plus 5. What are the two things that I need from that equation for me to graph this? Ashley? Yeah, I'm going to do my slope and then my y-intercept. Ashley, what's my slope? Excellent. And what's your y-intercept, Ashley? Excellent. All right, so we're going to go ahead. We're going to graph that. So I have 0, 5 as my y-intercept. That's pretty far up there, and I'm still going up. So I'm going to drop my x-axis down a little bit further so I can accommodate starting at 0, 5 and then going up. That way I don't have to take up too much room on my page. So 0, 1, 2, 3, 4, 5. Now I'm going to go up 2, to the right 1, up 2, to the right 1. My increments go that far. Okay, now I need to graph it. What type of line am I graphing? A solid or a dashed? So is it going to be a solid line or a dashed line? Rafaela? How many of you guys agree that's a solid line? Yeah, that's solid because I have that equal to as well. So I'm going to go ahead and graph that line. Now I've got to worry about my shading. It says y is less than that. Well, all of my less than y's, my smaller y's are down here. So I'm assuming that this is my shading. But then I'm going to check it. I'm just going to use 0, 0 to check. I do anticipate 0, 0 making that true because I'm assuming it's in the shaded area. Okay? So I'm going to go ahead and put that in. So I have 0 is less than or equal to 2 times 0 plus 5. So 0 is less than or equal to 5, and that is true, so I shaded properly. How many of you guys remember us doing these? Awesome. Okay, so now what we're going to do is we're going to take this and we're going to combine it with a system of equations. Okay? So for systems, so if we look at a linear inequality, the solution to a linear inequality is a range of points. It's a range of points. All right, and that range of points is our shaded area. Shaded area on the graph. All right, so when we have a system, just like a linear equation versus when we compare a linear equation to a linear inequality, a linear equation could have one point as its solution. A linear inequality has a whole variety of points. The same is true for a linear system versus a linear system of equations versus inequality. All right, so let's make that comparison real quick, and then we'll do these. All right, so when we talk about a linear system versus a linear system of equations versus a linear system of inequalities. All right, when we talk about the solution, the solution is 1 point, usually. All right, we could have no solution, which means lines are parallel. Or we could have infinite solutions, which means they're the same line. But when we talk about a system of linear inequalities, our solution, and we're going to look at this, this is the area on the graph where the shading overlaps. It's the area on the graph where the shading overlaps. So again, it's a range of values, a range of points. So for a point, to determine if a point is a solution to an inequality system or a linear inequality itself, any inequality, it has to fall in the shaded area. All right, so let's talk about how we figure this out. Who needs to see what's up there? So today we're just going to be graphing systems of linear inequalities. That's all we're doing. Natalie, are you cool, sweetie? Awesome. Does anyone else need to see this? Okay. So I want you to graph the system of inequalities. All right, so here are my inequalities. Y is greater than negative x minus 2, and y is less than or equal to 3x plus 6. Now, if they don't overlap, then it's a no solution. If the shading does not overlap, then it's a no solution. All right, so, again, we're going to graph these like they are equations. So I'm going to go ahead and turn these into equations. And then I'm going to identify the two things I need to from these equations to graph this. So I need to identify my slope, and I need to identify my y-intercepts. So in my first equation, what's my slope? Oh, negative 1. In my first equation, what's my y-intercept? Anastasia? Excellent. In my second equation, Lily, what's my slope? Excellent. Molly, in my second equation, what's my y-intercept? Excellent. So now, on the same graph, I'm going to graph these. Now, if you like different colors, by all means, you can do different colors, whatever makes it easier for you to understand it. Now, remember, when you're graphing these, you have to put them both on the same graph. So you have to adjust for your y-intercepts and your slopes and your, coordinating that stuff. Now remember, with a negative slope, your rise can either be negative or your run can be negative. Whichever one makes it easier for you to graph this. If I have a positive slope, how can I write that with negative values? How can I write that with negative values, Al? Yeah. So 3 over 1 is the same thing as negative 3 over negative 1. And for here, that might be smart to do, because I've got to go all the way up to 0, 6, and I don't want to have to make my graph bigger than it needs to be. So I'm going to use that negative 3 over negative 1 to help me graph from there. So on that second line, I need a solid line because it's less than or equal to. On my first one, I used 1 over negative 1 to find my other points. I decided to go up. Now the first equation, that has to be a dashed line. Why? Why is that line going to be a dashed line, Joseph? that one says I have my y is greater than that line, so I'm going to assume, I'm going to kind of say that this is our overlap. And I think you'll find that that's true. If you don't check it, I'm not making sure you check, but it's a good idea to check. So here, where they overlap, there is our solution. And I do need to see the shading individually for both of them for you to see the overlap. Now, if you're someone that kind of wants to then tell me what the final is, that's fine. So here is the final solution. Questions on this? Once you see them coming in, you guys can come. Just throw your stuff out there out in the hallway. Thank you for remembering. I appreciate it. Questions on this? Talk to me. Are you guys good with this? All right, well, let's take a look. So on that first one, that's this one right here. My red one is the first one. This is my number 1 line. Well, my slope is a -1. So we know it has to be going down from left to right. How many of you guys have questions on graphing the actual lines? Okay. So from the shading perspective, that first one says y is greater than that expression. Well, that expression is the line itself. So all my y values are going to be greater than or higher than that line, which is why I graphed on the top side of that. Now I can check that. I would expect 0, 0 to make this equation true, the equality true. So if I put 0 in, 0 is greater than 0 minus 2. 0 is greater than -2. That's true. So I did shade. I need to shade above that line. I would do the same thing on the other one. I have y is less than that line. So that means that I'm shading where y is smaller than that line. And again, if I put 0, 0 in, 0 is less than 6, and that's true. You guys cool with that? Okay, I want to give you guys another one. So I want you to graph y is greater than or equal to -1. X is greater than -2. And then x plus 2y is less than or equal to 4. Well, let's talk about these equations first of all. What kind of equation is that first one? What kind of equation or kind of line am I going to be drawing for that first one when I have y is greater than -1? Herman? It's not a diagonal line. What kind of line do I have if I have y equals a constant? Ryan? Nope. Y equals a number. So that means it's crossing the y-axis somewhere. What kind of line is this? Joseph? That's a horizontal line. And that's a horizontal line crossing the y-axis at 0, 1. So crosses y-axis at -1. So what kind of line does that mean x is greater than -2 is going to be? Natalie? That's a vertical line. And that's crossing the x-axis at -2. So x equals crosses the x-axis. Y equals crosses the y-axis. So for it to cross the y-axis, it has to be horizontal. For it to cross the x-axis, it has to be horizontal. All right, what do I have to do with that third equation for us to graph it? What do I have to do with it? Lily? Yeah, I need to turn into slope-intercept form. Natalie, or Lily, what am I going to do that? Oh, gosh, no. How about x? Because don't I want to get it into y equals mx plus b? So I want to get the y term alone. So I end up with 2y is less than or equal to negative x plus 4. Now what, Lily? Excellent. Divide everything by 2. So I get y is less than or equal to negative 1/2 x plus 2. Don't forget to figure out what that coefficient is. When I have negative x over 2, that's the same thing as negative 1 times x over 2, which is a negative 1/2 x. Now all of you graph this. Remember, on those two, though, that third equation, identify your slope and your y-intercept. On the other ones, there's really no work you have to do. You just have to graph those two, that horizontal and that vertical line. So in that third one, its y is less than that line. So we're going to go everything to where all the y's are getting smaller. All right, my horizontal line is y is greater than or equal to negative 1. So that's going to be this right here. So there's that line. This is y is greater than or equal to negative 1. Where am I going to shade if I have y is greater than or equal to negative 1? Where am I going to shade? Above the line or below the line? Natalie? Yeah, I'm going to say above because it's greater than. So it's above. All right. And then let me get a different color. Find my blue. If I do negative 2, so now, where am I going to shade for my blue line? To the right of it or to the left of it? I have x is greater than negative 2. Should I shade to the left of it or to the right of it? Giselle? To the right, because all my x's are greater than that line. So I'm shading in here. All right, so sometimes these can be hard to see the overlap. So my overlap, well, it's going to be starting at that vertical line, running to the horizontal line and across, and then to the diagonal. So my center, that triangle area, is the overlap. How many of you guys can see that? Can you guys see how using different colors can be helpful in these, or different types of lines, or like shading? Questions on this? You guys cool? Okay, that's all you're doing tonight is dealing with these linear inequality graphs. How do I know where would a point be that's a solution to this system? So where would a point be that's a solution to this system? Where would it be located? Rita? Yeah, it's going to be in that shaded area. So in our homework, if it asks you to decide if a point is a solution, you're looking to see if it's in the shaded area.